So the initial spark for the idea for Rotovelo actually came about 20 odd years ago. I had just recently offered my friend a ride of my Velomobile. Now this wasn't any ordinary friend, this is a friend who I had built a recumbent trike, who had ridden all the way around Australia on this trike and recently come back. He took my Velomobile for a ride and said, "This is awesome, Ben, but I can't really use this. I need something more durable, something more practical." Now Simon's opinion really mattered to me, as he had just spent 14 months riding a trike on the road and had really clear idea of the practical day-to-day use of the machine. So I had to take what he said with some seriousness. I'd recently purchased a kayak at the time, a rotomolded kayak, to go down to the beach in the summer, and the link was obviously pretty obvious at that point about the idea of using rotomolding to build a Velomobile. It was some time later before the stars aligned and I was able to really make this happen. Some interesting facts came to light. One was that there are more rotomolders per capita in Melbourne, Australia at the time, than just about anywhere in the world, due to a recent water crisis and a demand for domestic water tanks. I did some initial CAD, wanting to take advantage of the properties of polyethylene. Obviously, it's not as high as tensile strength and ultimate strength as things like carbon fibre or fiberglass. However, it does offer lots of toughness and UV stability and durability. This meant I had to come up with a shape which had less surface area to keep the weight to a reasonable amount, and sort of a semi-monocoque design. So very interesting, slightly different to the composites, but we wanted to retain all the functionality that we already knew from the composite vehicles. I also wanted this machine to be big. I figure if we're going to rotomold it, let's make lots of them, and let's get the world in Velomobiles. And so one key design criteria I had from very early was I wanted to be able to fit as many of these into a shipping container. The final number was actually 24. That's 3 rows of 8 on their ends in a 20-foot shipping container, as you can see in this CAD model. Armed with this CAD, I thought, right, I'll just email some molders and make this happen. I sent around about 35 emails to molders in Australia, and I got one response. And that response was Tim Lead at Melbourne Rotomould. And he was the only person who actually took the whole idea seriously. And not only did he take it seriously, he took the job on. The collaboration with Melbourne Rotomould and Trisled has been an awesome experience for us. An opportunity to work with larger industry and intensify what we're doing here and work out how to take a more engineered approach. The collaborative process and design development between Melro and Trisled was a really fun journey, and relatively painless for both of us, although obviously some real challenges in both the molding process and for us accommodating the design parameters of rotomolding to build the vehicle. The rest of this video is predominantly Tim from Melro going through his process of building us a Rotovelo shell.
Hi, I'm Tim from Melbourne Rotomould, and if you haven't guessed, we're the people who do the actual rotomolding part of making the Trisled Rotovelo. And the purpose of this video is to give you a behind the scenes look into what goes on into making the actual Rotovelo. And the first thing I wanted to say is actually thank you to all the customers all around the world who've bought the Rotovelos. We really appreciate your support, and it's humbling, and it gives us a great sense of pride to know that these things have gone not just around Australia, but all around the world. So thank you very much for that. This is actually quite a technical part to make. It breaks many of the rules for rotomolding, so there's many parts in here, parts of this product where it's sort of difficult. So it pushes the boundaries of what can be done, but that's part of the fun of it. So the very quick intro into rotomolding, the 2-second introduction into the process is this. So what we do is we take plastic that's in powder form and it's pre-mixed to colour. And what we do is we tip that, doesn't stay in the bag, we tip that inside a hollow mould. Here's an example of a mould here. So we load the plastic inside, we then close the mould, and then the mould usually goes inside an oven, and we rotate the mould around, and the plastic's actually attracted to the heat, and it builds up on the inside of the mould, and we can control the thickness by varying the heat and the rotation settings. So some of the geometry controls where the plastic actually goes, but we have control by varying the heat and so on as well. Now once it's cooked properly, it's like making a cake. The mould comes out of the oven and we cool it down carefully, and then once it's cooled down, there's actually a temperature sensitive release coating on the inside of the mould. So the part releases off the mould. So at that point we can split the mould, and then your part comes out. Something like that. So it sounds easy, but obviously there's a lot more to it than that. Now with moulds, there's more or less two main ways of making the moulds. So this one here is a little cast aluminium mould, and then which is really good. But the other way of making moulds, which is actually the way that this one was made, is hand fabricated out of sheet metal, and that's the way that this one here was made. Would have been better if it was cast, but TriSled were taking a very big punt on this product because it hadn't been done before, and so a fabricated mould worked out a bit cheaper, so we've got to save money. So in the next video we're going to show you how that's actually done.
So Rotovelo started life as a 3D CAD model, but how do you convey a complicated 3D shape as 2D drawings that a toolmaker can actually make? And the answer was to actually get a laser cut pattern made up, which we fitted together to make this pattern, and then the toolmaker wrapped individual pieces of steel that he'd shaped with an English wheel onto this actual pattern to form the part. It's a bit of a work of art by itself, if I do say so. It was so much fun putting this together, but it was the only way to get the mould made. This is a view of one of the halves of the mould from the inside. You can actually see carefully, if you look, the actual join lines where the individual pieces were wrapped. This is looking at the breathers and a couple of temp probes, so we have to monitor the internal air temperature as the part is cooking. We use Venturis, so they're air movers, and it just concentrates extra hot air down into the seat recess because it's difficult to get enough hot air in there during the cooking process. So a small amount of compressed air induces a larger volume of air inside the oven to flow, and it gets down into that cavity. And it's important because if we don't get enough heat in there, then we don't get enough material thickness, so the pipes sort of distribute the heat down where it needs to go. And that high pressure air runs through that rotary union, high pressure lines that run in through the arm. We're just following along the paths, looking at where they go, and it sort of follows this path down around along to the outside of the mould and then connects up. We also have low volume, high pressure, low volume internal cooling air that comes through this pipe that you're looking at here that actually runs through the centre of the arm. This mould runs on what's called a rocking oven, so the mould rotates on its arm. We can direct this air inside there. Now we're assembling the two main parts of the mould. So the operator's got to carefully guide this section down, and then once it's down, sitting into place, it gets secured with a whole lot of bolts, and it's important to not have gaps in between because material could flow out. And it's quite a complicated process, but it's not too difficult. It sort of lowers that down. You'll see it sort of little pre-center guides and whatnot, and holding it into place. Drops down. It's too heavy to lift by person, obviously, so use a crane. It's quite a manual process. It relies heavily on skilled operators in order to get this all to work properly. You can automate, but only if you've got high volume. We don't have enough volume of this part, not yet anyway, to justify going full automation. So this is loading the plastic powder. In this case, we actually load it into a hopper first. So the next shot they're running was green. So the plastic and powder forms inside the hopper there are ready for us to load it. Now ordinarily you think you'd load the material in the mould, but we don't actually do that. We actually preheat the mould first. It's one of the tricks that we do. So the mould's going inside the oven now. It's rotating. We're actually just preheating the whole mould. And there's some very good reasons for doing that. As I mentioned before, it's a really technical part to make. It's incredibly sensitive to the heat, and it's actually quite a thin part, so we've got a very small window in order to get it to lay out properly. So the mould's now preheated, it comes out and it cools down a little bit more, and then the next step is actually actually loading the material into the mould. So they pull out the breather point. That's where they're going to load the material into, and then he gets the hopper and puts that in position, and then we can drop the material in there. This has all sort of got to happen according to the correct temperature and within a certain amount of time to make sure we get a good part out. So the material sort of flows. It's easiest to imagine it's like a liquid. It's not, but it's easiest to imagine it's like a liquid. So they open up the valve once he's got the thing sitting in the right place, and then the material all flows through, and then throughout the moulding process it behaves like liquid. So imagine it's sitting in the bottom of the mould, and the mould sort of is rotating past it, and the material is moved around inside the mould, but doesn't rotate very fast, so it's not centrifugal or anything like that. The material basically stays on the bottom, and once it starts to actually cook, it starts to stick. So now it's just going in to cook. So this is what's called a rocking oven, and it has what's called a rock and roll motion, and it's a shuttle machine. It's quite interesting actually. So that's a cart, there's another cart on the opposite side. So the cart's rolled in, the doors of the oven close, and then this oven then raises up into the air, and then it rocks. You can get other types, but this is the one that we've got for this particular part. So now, and you can see it's really fast, the oven's raising up into the air. Now, the whole time with this going on, the mould is rotating on its arm inside the oven, so it's already been preheated. And what's happening inside there is the material's been heated up, but it's not really sticking to the inside surface of the mould yet. It's not hot enough. Now we're carefully monitoring the internal air temperature of the plastic inside the mould, and so all of this is a lot of research and development goes on into getting all the temperatures and times and everything set up correctly. So it's not really sticking to the inside of the mould yet. The machine is just raising slowly up, and then once it's got up all the way, then it actually starts rocking, and that's where it gets the rock and roll name from. So again, we computer controlled all of this business, but it rocks up and then bed level, and then rocks down and bed level, and then we can control all those durations in order to get the material to flow where we need it to flow, along with the heat. So this machine's got a burner up the top, and then it's got a great big recirculation fan, and it's like a fan forced oven. And in this particular machine we can actually optimize the airflow, which we've had to have done in order to make sure the heating's nice and even. So we use thermal imaging cameras and so on to have a look at the heat distribution on the mould, and then you make some changes to optimize it so that we're getting the material to go where we need it to go. So rock and roll. So remember, the mould's rotating on its arm inside that oven, and then the oven's rocking up and down, and that material's sitting in the bottom of the mould. So as it sort of rocks from down to bed level and then back up again, that's allowing the material to flow. And then it's starting to lay up on the inside of the mould. We actually cook this quite slowly because it's so thin. We need to increase the period of time that it has to lay up, which is the part that we actually control where the plastic goes. It's not the most exciting thing to see in the world. All the action's happening on the inside. So now it's finished cooking and the oven's just lowering back down. I'm not going to show you the whole process of it coming back down. You get the idea. It's got little guides and things that sort of make sure it locks into the right position as it comes down. So then once it's all the way down, the doors open, and then the cart come back out, and then you'd think those great big fans that you can see in the back there would turn on, but they actually don't. And that's because we've got to be really careful with the cooling side of things. So one of the things we've got to be aware of is causing a part to warp. So if you cool a part from the outside only, you actually get differential rates of shrinkage through the wall thickness of the part. So the outside cools quicker than the inside, and that changes the crystal structure of the plastic and can cause the outside surface to shrink more than the inside, which can actually cause it to shrink. Now, why am I telling you this? Well, with flat parts, and the flanks of the Rotovelo are quite flat, that makes it quite difficult to get it to actually hold the right shape. So we don't actually turn on the external cooling fans. In the case of this part, we'll actually use the internal cooling. And that's what's happening in the next step. So now I'm not actually showing you the internal cooling working, that's one of our secrets. Anyway, so now we've pulled the seat insert out and we're just looking inside at the formed Rotovelo. And the next step is he's undone all of the bolts in the other part of the mould, and he tries to rip the internal temperature probe off, and then realises, and then moves that out of the way. You see him jump. So you can see the part there, and when we look closely in a second, you'll actually see that the plastic part is actually smaller than the mould. So we get about 3% shrinkage all up, and we get about 2% straight away. So the plastic part is actually smaller than the mould itself. It's like a brand spanking new Rotovelo shell. You can see the gap there between the mould and the part itself. So then we rotate it round, and then in this case it's a 3-piece mould. Once the parts of the mould are all separated, that part itself actually comes out quite easily. That's it, job done. Actually not quite. So they've got to trim out the top, we've got to trim the part lines, so you get a little bit of flashing here and there where the joins of the mould are. So they've sort of got to go and sort of clean that up, touch it up, whatever. We trim out the top, and there's a whole lot of other quality control inspections that we do, and then it goes off to the tri-sled factory, and they put the frame in it and all the clever bits. So just here you can see them just trimming some of the edges. Again, it's just a person doing it. It's not robotic or anything like that. So just going through and just carefully making sure everything's okay. So that, ladies and gentlemen, is basically how we do the rotomoulding of the Rotovelo. Thank you very much for watching.
So I hope you found that as interesting as we do, all of the many steps in making the polyethylene perform well and actually create a usable Velomobile using the rotomoulding process is an amazing achievement for Melro, and one that we're very grateful for here at TriSled. In the next video, we're going to show you how we at TriSled actually do all the final trim of the shell ready to fit up to the chassis, a brief look at some of the frame building techniques we use to build the frame, and assembly of the machine. So please like and subscribe to the channel, and hit your notifications button so that when we actually get around to publishing that second video, you will get a notification and you can see it. If you like this video, you'll probably like some of the other stuff we do. We do all sorts of custom human-powered vehicle projects and special builds for people. Please like and subscribe, as I said, to the channel. Tell your friends about us, and we'll see you in the next one. Cheers!